This week we are looking at something I forgot to put on the syllabus, but very important. It's chapter 4 of your text, the human sphere, and therefore I will be doing part 1 of climate, which was scheduled for this module, and then I'll do climate solutions or strategies next week and put that on the water. So, but it's very important. Key. There's a lot of key material here. Technically, since this wasn't on your reading, wasn't assigned, you can just this is based on the reading. So if you want to just do on what I want to say, or if you want to check your text just to kind of get a better context, by all means do so. One sign of environmental degradation was a formula that Paul Ehrlich created years ago. And remember Paul Ehrlich with the population bond called IPAT. Again, you can find this in your text. It's on on page 44. Okay. And IPAT stands for the impact on the environment equals the population times how affluent one is. In terms of our footprint, we've already talked about that, times technology. And technology can go either way. It can either accelerate the footprint, the impact, or it can, do things to reduce the impact. So it could be positive or negative or some combination of which. So again, I mentioned Paul Ehrlich formulated that. So it's the product of the size of human population, their affluence or consumption per capita, and the technology that determines the environmental impact of each dollar spent. Okay, so I said it could be either good or bad. One thing we do see is human population growth, which has, after you see that 1712 was it we have the steam engine invented, and you can see right after that, especially beginning of the 20th century, the latter part of the 19th, 20th century, population starts to explode from the billion part in in the 1800, 1 billion people, to now we are well over, projected into over 9 billion by the mid-century. So you can see how that's going in exponential growth. And again, more people who want to live like Americans. The average Bangladesh person had a carbon impact or ecological footprint 1/40th the size of the average American. But what happens when that person sees TV and starts to get educated and starts to want to live like we do? So, we'll get to technology later, but there may be some good news in that some of the heavy-duty fossil fuel-oriented stuff, like you go from cell phones or power plants, you can start to go directly to solar, for instance, which is as they start to grow. And the rule of 70. This is the estimate of how many years it takes the original amount to double. And it's just useful for calculating population growth. I mean, rule of 70, I do this with my savings, my IRA, my financial planners worked over this with. So it's kind of a rule, many different applications. So here's the question. 70 divided by the annual growth rate equals the number of years to double that amount, or number of people. So if a population growth rate is, for instance, is 2%, then 70 over 2 equals 35 years to double. If the growth rate is 7%, then 70 over 7 then would equal 10 years for that population to double, and so on. Now, what are demography, which is the science that really addresses population issues? One thing, these are important key parts. This first part of the course, I said there's going to be a midterm, but no final. And the reason there's going to be a midterm is that there's a common language. They kind of everybody sing out of the same hymn book, that if you're going to be conversant with issues around sustainability, we need to get a little grasp about that. So When the time comes, I'll give you some hints how to approach studying it. But these are these terms in bold. So population ecology is, and this is most of this directly from the text, the study of growth, decline, and changes in population. Demography is the field where the statistical principles of population ecology are applied to human populations. When I was in grad school in sociology at the University of Michigan way back when, I took a class in demography, and I took another class in human ecology. So that fact, demography ecology was my, cultural belief systems was my major focus, but ecology demography was my backup area, if you want, my minor. And so demography measures the birth rates, the total number of people who are born in a given year. It measures the total fertility rate, the number of children born to a woman in her lifetime, and it measures the replacement fertility rate, the number of births per woman that will keep the population size constant at zero population growth. So I think it's usually around 2.1. You got mother and father and then 2 kids, and why 2.1? Because you do, even though it's very low rate, you do have occasional infant mortality and the like. So I think that's around where zero population growth is. So it's and you see that when pops, like when societies such as Japan went through the demographic transition, had less than the replacement fertility rate, that was an issue. You've got, and we'll see this about the challenges, yet the sweet spot, if you will, when you make that transition. So there it is. It's a little complicated task, but again, I already addressed this, that you go from high death rate, population, and high birth rates and high death rate, that's high stationary. Then the expanding phase, 2 and 3, where the birth rate remains high, but then all of a sudden, because of science, like pesticides or the Green Revolution, some education, the death rate takes a big drop, and that's where the population, that society is really going to explode, and you're going to get a lot of young people. And you see that in a lot of the developing world compared to Europe and North America. And then you get to a point, the low stationary, where then the birth rate then comes down, and everything becomes stabilized. So you see that population all of a sudden, boom, shooting up, and then by 4 and then 5, it can start to decline or be stationary again. And you can see some of the reasons there. Many children needed for farming, early age, diet in early age, religious social encouragement, no family planning, improved medical care and diet, which I just said, fewer children are needed. And then you have family planning, good health, improving status of women, later marriages. And the big one there, which isn't in this chart, is education. And so, and then you realize the death rate's coming down. Where the changes. So first, a lot of disease, famine, poor medical knowledge, many children die, improvements in medical care, water supply, forgot to mention that, sanitation, cholera has gone down, etc. And then you have good health care, reliable food supply, so there's a new stability there. So the demographic bonus is countries that successfully navigate the demographic transition. If they do that, they can tend to have a relatively lower proportion of children and elderly. That's in the middle. We had that in some ways with like in our case, I remember the boomers. The upshot is that rather than have to allocate more resources to education and medical care, on both ends of the spectrum, education, the kids, and medical care to the elderly, right? Those resources are released for economic activity. For instance, they can reduce poverty. This is only a one-time thing. You only go through the demographic transition once. So you got maybe a generation or two, 30, 40 years of to take advantage and before you get that things stabilize again. So the dimensions of social progress, it's essential for stabilizing the population. Education. The key in developing countries is in educating young women and giving them career opportunities. And then you've got, they're the poster child, Nobel Prize winners, Malala. Okay, who's now, can't believe she's only 21 to, I think 21 or 22. She's, last I checked when I making this presentation, originally she was a college student in England. Employment, especially for women. Then they'll have other choices and hope for upward mobility. So as jobs open up for women, education opens up for women, and that is more than anything else. If you want to bring down the population, or that is it because they're going to put off getting married. They see another way out instead of, there's only one way. It's just a mother, and they can make a difference, and also put their talents to addressing issues in the economy like technology and other social development. The reproductive health, and that's the third part. Not only knowledge of family planning and access to tools, such as I know they did for condoms, but also protection against STDs, which is, if you look at AIDS, for instance, in Africa, that has been devastating. So if you can start to get a hold of some of these diseases, you're in much better shape. Now they talk about economics. Economics, in the last 50 years, as we mentioned, population has more than doubled, global consumption of water has more than tripled, and the use of fossil fuel has quadrupled 4 times. And now we are what we call the sixth extinction. 50% estimated that by the year 2100, 50% of the species around by the year like 1900, within 200 years, will have gone extinct. And we see that since 1970, there you see on the right, we've lost 52% of the Earth's bird, mammal, fish, reptile, and amphibian populations. 39% for land-based species, 39% for marine species, 76% for freshwater species. And I know that people here, in life sciences, humane studies, that whole track, this is very, and I know it's near and dear to many of your hearts. So this is another reason why these are all related issues. You can't just look at taking care of the animals with looking at the habitat, and we look at the environment and looking at what's happening, population sprawl and all kinds of things that we'll address throughout the rest of the semester. And most large fish have disappeared. The deserts are growing, and mountain glaciers are retreating. They say by mid-century, Glacier National Park will have no more glaciers. So what's the driver of change for economic growth? Again, it began, as I show that demographic transition slide a little bit back, in around 1712 with the development of the steam engine that fed on coal. And if people in the Detroit area, you can see these early 18th century steam engines. Go to the Henry Ford Museum. It's a phenomenal education. Adam Smith promulgated the notion in the Wealth of Nations that division of labor will increase productivity and therefore material wealth. And then what really came about with this driving force was World War II and following. There was an explosion of technology and monetary wealth generation. And globalization, is another driver of economic growth. Like I said, if someone is in some place in, Tanzania, but they're watching TV, satellite TV, and they're seeing, some Melrose Place or one of these rich and famous Americans, I say, I want that. There's something human wants that strives for better material life. It's in us, and the problem is, we'll say in a little bit, that we can look at we can conflate that with better quality of life. And I mentioned that one of the videos that I have for this week is an old oldie but goodie, and I'll mention again affluenza and then escape from affluenza. It's not required, but I would really recommend at least see a little bit of it to get a flavor of this. It's incredible. It's an addiction. It's a disease, they were saying, like influenza. It's a plan words, and of course we got that teenager a few years ago who said that he had affluenza disease, and he said, yeah, right. Neoclassic economics, and this Neoclassic is what most the driver is the assumption that markets have an inherent, efficient logic subject to supply and demand. Assumption that the markets always choose the optimal alternative. On the other hand, environmental ethics says that human welfare depends on the biosphere. It looks at a much broader, again, systems perspective. Remember, for those of you who watched Mind Walk, it assigns value to the ecosystem services and pollution so that they can be incorporated in the, the cost-benefit analysis into the market calculations. And it recognizes that growth can't go on forever, and that nature has placed limits with which humanity must come to terms. Again, some of this I'm taking directly from the text. So there's growth versus development, economic growth versus sustainable development. Okay. Economic growth looks at things specifically as quantitative, and it measures the size or increase in production. And it really, we'll see that second when we get to GDP, it doesn't matter how you calculate this stuff. Sustainable development, on the other hand, is qualitative. It measures the increase in quality of goods and services without necessarily a measurable increase in the quantity. So it's quality, better life. And again, I can't think of anything better that exemplifies that vision than something like Mother Earth News and what they, it's a soulful, mindful way of living. And I know there's some, when we talk about our footprint, those are kinds of things that can be addressed. Capital versus natural capital. Capital is wealth used for the production of more wealth, money or material supplies. Natural capital, on the other hand, includes ecosystem services and physical natural resources. The problem with the traditional model is that it treats, as we'll get into this later, the climate costs and public health costs of burning fossil fuel as an externality. It's not factored into the real cost of a cost-benefit model, to folks somewhere else, to, like, say, as I mentioned last time, like the forests in Nova Scotia, we're getting, acid rain, to non-human life, who are the corals, there'd be acidification of the oceans through climate change, to carbon absorption, to the impacts of our future generations. We mentioned stakeholders, who's got a voice at the table. And I bring over there, and come back to this, Bob Inglis. You see his picture on the left side of the slide. Bob was a congressman who got booted out by the Tea Party out in 2010. Very conservative Christian. However, he went to Antarctica, and he was, through his kids, he was awakened to the reality of global climate change. So he said he still believed in the markets, but his argument, which I think is very cogent and something with which you can have a discussion, is if this is a really big dire emergency, then what one needs to do is factor all those costs, comparing the real cost of coal, the real cost of oil, the real cost of even natural gas, as compared to the real cost of solar or battery storage or wind, even hydro, and then see how that shapes up. And he's saying, when you factor those other so-called externalities, they're no longer treated as externalities, then the cost benefits become very clear. So just because one is politically conservative and really believe in markets doesn't mean that you neglect the science, and you can take those strategy, incorporate those mechanisms to addressing a problem we all have in common, or challenge. I mentioned gross domestic product versus genuine progress indicator. Your book, uses another kind of a thing too, but that's fine. It's gross domestic product is developed during World War II. It measures all economic activity. Okay. The problem is it also measures deleterious economic activity. For instance, car accidents, toxic spills, hospital visits, crime, all those things. So when things are happening, that's measured as a measurement of GDP. It's not necessarily a good thing. But genuine progress indicators have been also constructed. And it doesn't measure the well-being or the differentiate activities that harm the environment from those that regenerate our planetary system. A genuine progress indicator, on the other hand, does measure economic social welfare. It includes the costs of environmental damage, pollution, crime, income disparity, national debt, so that you get a real sense of this. And it includes benefits of on the positive though, of volunteer services, childcare, that kind of thing. That are social benefits. Remember our triple bottom line, people, profit, planet, that all three of those have to be put into account, or environment, equity, and economics. And then, like measures of GDP, the GPI and similar measures have been in decline since 1978. And even measures of well-being or happiness. So what this calls for is a new paradigm. And if you recall, when a couple weeks ago we talked about paradigm, a paradigm is a worldview, our basic assumption about reality. And the classic case was going from a paradigm in which you see everything, the planets and the stars circling the Earth, to which the Earth circles the sun. That's a new, different way of thinking, which needs a shift to go to a circular economy, not just a throwaway economy, where you reuse and recycling of non-renewable resources. And it's also, the book talks about decoupling. That's the condition in which the development occurs without increases environmental impact. So there's a couple more terms for you. So, decoupling means that we can have, again, sustainable development, quality of life. If you're ever interested in that, Jeffrey Sachs has a wonderful book out. This came out a couple of years, which is like the encyclopedia of sustainable development. You can get that at Barnes & Noble and stuff. I do mention the Story of Stuff project. You can look that up. I'm going to probably put that. There's so much video that I have for this week. I didn't want to load you down with that, but I probably will when we, more about that in a couple of weeks, which really, in 20 minutes, a great video animation illustrates why the need to go to a circular economy. And the book also talks about failed state versus a failing state, or not versus, but failing state is on the road to a failed state. A failed state is one which you can no longer can govern, and you need governance. It's a state in the state of disintegration. The natural world is a casualty of failed state, and a failing state are on their hands on the road to disintegration. You can see Haiti. That's a classic picture of aerial photography between the border of Dominican Republic and Haiti. Dominican Republic still has all its forests, but Haiti, which is a failed state, people need to burn stuff because they got to survive. They're not going to think about green or the commons or future generations. When you're drowning, you're thrashing about, and that's the casualty of this failed state, is that the natural world gets trashed. And, same island, right next to each other, but a whole different approach and implications of a failed state versus one that still functions. And again, desperate people in poverty can't think of protecting resources. That's why you have to have good governance people have to hope. There has to be some mechanisms in place in each state so that you can think of the future. And the question comes out, stakeholders. We mentioned it before, but this is the key. Again, stakeholders, who's got the voice at the table? So you got land grabbing, where affluent countries with insufficient resources such as water lease or buy up blocks of land in poorer countries. And stakeholders are persons or groups with a stake in the outcome of a decision or policy, those who will be affected by the decision. And there you've got Standing Rock, the protests about the concern about water as the oil pipeline comes through from the tar sands, and say we are water, that we have to protect. That's an irreplaceable resource. Can you go without oil? It'll be maybe difficult challenge, but yes, can you go without water? No. Next to air, that's air, shelter, water. Those are the big three. The commons is classic. It means common pool resources, resources from which it is difficult to exclude groups or individuals. That is, so that the use of resources by one person will decrease the benefits of other persons. Examples: forests, fisheries, the atmosphere, etc. In fact, I saw one person using a carbon tax initiative. They a number of years ago proposed a nice little booklet using the fact that our atmosphere is a commons. And we all breathe the same air, as JFK said. The commons then is a common pool of resources plus a set of protocols, the rules and social practices then for managing resources. Do you have government policy? Do you have like treaties and laws, or do you have a private landowner who has a vested interest in that? So those are a couple ways that you can address that. Someone's going to exploit that. This was first proposed a number of years ago, the tragedy of the commons, by a famous Garrett Hardin, who proposed that years ago. And the classic case I use here because I kind of went to Newfoundland and saw what happened was the collapse of the cod fisheries. There was overfishing, and it wasn't all the people from Newfoundland's fault. It was all these European coming into their waters with these big nets and trawlers, kind of grabbing up all this cod. And as technology improved, you can see by 1970, this cod fishing was remarkably stable for a long time through about 1960. And then that decade, new technology just they all this will be more, but you again limited resource, limited area, and they couldn't replace the cod, couldn't replace what they were extracting out of it, it's like a resource. And there was a big collapse, and people, around 1980, and there was a warning. They say, "Can't you see?" There's a warning sign, and shot across the bow, and people said, "No." So they said, "No, this will not be a problem." And yeah, it did go up for a couple more years, and then about 1992, the bottom falls out, and it never has returned. In fact, when I went to Newfoundland, I've been there 3 times actually, that it's tourism. They had to turn to tourism, and they showed how cod fishery used to be, because the actual cod fishing now is like in farming and other things, but not so much in Atlantic cod in the wild anymore. But that's example when the commons is under assault, when there's not enough regulation, or someone can't enforce the regulation to husband this, and human greed gets in the way. They mention there are some ways to go. Your text mentions Elinor Ostrom, and I've used her before, not because they've got so much going on, but she has ways that it's not always tragic, that there's other mechanisms that you can, you can do this, and if you're interested, you can look at those things. There's ways of resolving disputes, and external government do not, that the government doesn't do too much mucky muck, is subsidiarity, but there are some checks and balances. So, and there was one video I showed in the environmental ethics class. It's really cool. There's little commons, this really garbage area in some place in a city in India, and all these people get together and they clean it up. They all clean it up, and it becomes a park that everybody uses in the neighborhood. Okay, so there's a positive use of the commons. Okay? Parks, and it's this question we get to urban buildings and stuff. There's, an urban planning issue. You had town squares, you used to have the commons, where they used to have the gazebo by the courtyard, and you see it, these old things from the turn of the late 19th century where bands would play and kids would play in the park and everybody come together in the city parks. What happens when you have that, when it was replaced by malls, where then that becomes privatized and there really is no more commons area? So what's the implication of that? So we are now going to part 2, issues and solutions. And since there's so much that's already been covered, I said I'm only going to do part 1 of climate this week, and we will finish up with potential solutions and strategies and policies that can address climate change and the potential deleterious impacts of that next week. But so we'll get into things like issues like climate, water, the food, and then we will get into more specifics like later on, of course, like buildings and green buildings and communities and manufactured products. So get down the particulars. So this is the first one, climate part 1 today. So climate trends. First of all, climate and weather are different. Weather addresses the atmospheric conditions and patterns in the here and now. It's very cold, the polar vortex is here. However, don't forget that it may be very cold here, it may be super hot in Australia, or because their weather's, when it's our winter, it's their summer, and vice versa. There's also, we're looking over a brief period of time or even over the course of a better part of a year, but climate looks at long-term trends. So you can see that the annual mean temperatures around the world. There have been times, I know a couple years ago when it was cooler here in Michigan, this was like maybe in 2015, 16, and you looked at that map like something like that throughout the year, and most of the world was on the red side, or yellow, like warmer than usual. But there were like 2 pockets. There was something in the North Atlantic, and then there was around the Great Lakes states. We were in the epicenter of a cooling island for that year. And yeah, Detroit's temperatures were that year were below average, but the rest of the world was, almost the entirety of the rest of the world, especially in Europe and some parts of Asia, was way above average. So you've got to factor in the whole planet. And an example I use is analysis. Okay, think of it this way: if you've done this, so you look at observable, and I just pluck that in there, and so at a certain point in time, and you put and how much was the measure of whatever, and you put that dot there, and then you go there, and over time you look at these other dots, and then you calculate what least squares. What's the line that would be the most, make the best fit of all these little observables, and that's the regression line. Think of those individual observations as a weather. Some days they'll be higher, some days they'll be lower. However, if you look at the overall trend, like the regression line, that's climate, then you can see a particular trend going on. There's always, I want to mention, there's always 2 questions I ask when you're looking at studies, especially in climate stuff, because there's so much thing about ClimateGate and other things, and people looking at websites that claim to speak for real science. But is the study peer-reviewed, and who's paying for the study? These are why these are important. Now, in peer review, study is submitted to fellow experts in the field who attempt to give an objective critique of the research methodology, the literature, and how it relates to the theory. Although it's imperfect, the peer review process has been a backbone in scientific research. You do have gatekeepers, kind of sifting the wheat from the chaff, and the peer review process is across science. How you do? I've submitted a couple papers to peer review process myself and gotten published with another author. And that that gives you a lot more confidence that you're not really, am I off the rails or whatever. So is there people in the field, like say in the area of climatology, are there people, respected people? They say 97% of the climatologists, accept the science, and then it's very key in assessing in using and when you have politically charged climate research, assessing that, has it gone through that process? Because if it has gone through that process and they come through something, even if it's contradictory, then that's something in which you can rely. The other question is the funding source. Is the source of the funding for the project a grant? Does it come from the fossil fuel industry with its own agenda? I know they're the favorite whipping boys, but the Koch brothers, for instance. An example here, the Koch brothers, there's a Berkeley physicist, University of California, Berkeley, who said, well, the temperatures had to do with why it was warming. It was because there's heat island effects. That's why it was. And if you control for that, then there wouldn't be a problem. So the Koch brothers set up much of money. You paid for the research because they thought that was, that was what he said before he went into the research. And then they even set up a meeting, with some folks in Congress to give a hearing. So he was looking, they're looking at heat stations funded by fossil fuel, looking to discredit and testify for this person before Congress. However, when he did controls, his research backed up the climate research, even though he had expressed doubts before the study. Again, peer review, he had to let the science, he had the integrity, the science spoke, and so when the hearing came, it wasn't what they were expecting. And so, as it says, the Earth is warming. We see thousands of years ago how during the Ice Age, the temperatures have gone up and down. It has been warmer than it has, but it's you can see it's climbing quite steeply. There's been other times when it's been a steep climb. And we say, well, why there's more ice now? You look at the global land temperature. You look at the little spots, or the annual average, and then you look at over 5 years. Again, remember we like the regression line, and you can see that over 5 years, the temperatures from between 1880 and the year 2000 had risen, and they continue to rise. As we said, the Earth is warming. Temperatures are rising at twice the rate on land as at sea. They're rising faster in the northern than the southern hemisphere. Temperatures have risen 4 times faster in the Arctic than the rest of the world. Now, you might say, well, the Arctic, the sea ice there, it's always on the open water, so it's not going to raise ice temperatures, any melting ice there. However, you look at Greenland, and then in the southern hemisphere, you look at Antarctica. All that ice, when it gets melted, that is going to increase the volume of water levels in the world. It's just like dropping a new ice cube in your glass. And you think of how many people, percentage of the world, lives along coastlines. The Intergovernmental Panel on Climate Change, the IPCC, estimates that the increase in temperature will be between 1.5% Fahrenheit and 8.5 degrees Fahrenheit warmer by 2100, than it was in 1900. That's just 200-year span. Could be that 8.5 that's the upper limit, but there's disastrous. There's a question about 6 degrees can change the world. What happens if the world rises 1 degree, 2 degrees Celsius, 3 degrees, etc. And in the last ice age, global temperatures were only 9 degrees Fahrenheit cooler than they are at present. So it doesn't take a lot of a shifting to really shift. You say a few degrees here, a few degrees there. It makes all the difference in the world. And seawater is becoming more acidic. And the Earth's warming. There's differences now between daytime and nighttime temperatures are decreasing. That's a sign of warming world. The mid-latitude growing season has gotten longer, so I know people are growing, like wineries are even in England now are happening that didn't used to happen. There's more droughts, of course, and forest fires. We look in case in Point, California. The intensity of storms have increased. So again, there may not be more tornadoes or more hurricanes, but the level 4 or 5 of those, category 5 hurricanes or F5 tornadoes, that proportion is increasing because you're feeding more heat energies feeding into those storms. And the Earth has been warmer in the past. It was much warmer in the dinosaur era, Jurassic world, if we will. But however, the current acceleration rate in the rise of temperatures is unprecedented. It's on steroids, which we don't know how they adjust. It's not a slow, gradual increase. It's dramatic. So how are the Earth's temperature records are compiled? So if you look at the past 150 years, as your text points out, use actual measurement. We have good measures that's been there. Ship logs, cities and stuff. They can measure that, so we can see what's happening. Since the latter part of the 19th century on. But we use what they say proxies, things that stand in for others. For instance, tree rings is used a lot. And their thickness responds to temperature variations. So you can see depends how wide that ring was, whether warmer or colder at that time. That's a proxy. Coral reefs, again, how much they're growing. They work best in warmer tropical water. So it depends. You're doing the tree rings maybe in the temperate part of the world, like our part of the world, and in the tropics, especially in the oceans. Then you look at coral reefs as a measure. And then looking at lake bed sediments. Pollen at each level tells something about the plants and the temperature, and what they could tolerate when they were first formed. So you can look at layers of those again in lake beds. And a big one is ice cores. If you go in Greenland, in the Arctic and Antarctic, I know there's work at Ohio State where they've got these core bubbles. Or if you saw the movie The Day After Tomorrow, about the global warming movie back in 2004, when the disaster ones were great special effects. That's how the movie begins. They're at in the Antarctic, and they're doing that. They're taking ice core samples. The bubbles at each layer of the core sample gives temperature estimate at the time that core was formed. So you can see how those temperatures have changed over those periods. So there's some very clever ways that they can approximate what's been the climatic trends of the past. And there's things that you have to take into account, like the Milankovitch cycle. The Earth's axis changes the angle of its tilt over a 41,000 year cycle, from 21.8 degrees to 24.4 degrees. And currently we're at 23.4 degrees, and it's decreasing the angle, so we're going towards the 21.8. The less the tilt, the less there's differences between summer and winter temperatures, right? It's more straight up. In addition, the Earth wobbles on its axis, so you have to take that into account too. We kind of wobbles like a top. You spin a top and it kind of wobbles a bit. And if there were no human impact, actually, if they take all human impact right now, actually the Earth would be slightly cooling right now. If we didn't have if the Industrial Revolution never had occurred, the Earth would be in a bit of a cooling phase at the moment, which it's not. So we talk of the good old greenhouse effect, and certain gases such as carbon dioxide, CO2, methane, CH4, and water vapor inhibit the sun's energy heat from easily escaping back into the atmosphere. These are what they call triatomic gases because their molecules consist of 3 or 4 more atoms. They vibrate at the frequency of infrared radiation. Other common greenhouse gases include ozone, O3, and nitrous oxide, N2O. See, there's you can look at that. There's 3 atoms making up those molecules. So they kind of do a block, or they inhibiting effect, keeping heat escaping. But the simple 2-atom gases, such as nitrogen and oxygen, have little heat trapping effect. And now these are the 2 most abundant gases in our atmosphere. Nitrogen is like 78%. Now oxygen is like 21%. So, you've got almost like just 2% that's left over for the other gases. But they're the ones, they're making all the difference. And past records show a strong correlation between carbon dioxide levels and temperature. So there we go, CO2 and temperatures. This is some, the red one's Mauna Loa, which is a Y which they've tracked for a number of years. And you see those up and down. That's because there's more CO2 released, I think in the summer, or no, I forget the summer, winter, but they reverse. So it's the amount reported in parts per million by volume, ppm. And during the last ice age, it was around 170 parts per million of carbon dioxide. Most recent history, it was at 280 parts per million. Okay. However, now it is over 400 parts per million, the highest level in 3 million years. So I think it's the summertime. If I'm thinking about it, the winter, the levels go up because you don't have the plants to absorb the carbon dioxide as you do in the summer when they're full bloom. They can take some of that out. So there's where that angle comes from. This is the National Aeronautics, Ocean Aeronautics and Space Administration. So, so the text talks about global warming potential. This measures the impact of other greenhouse gases relative to carbon dioxide. So 1 ton of methane has the impact, given the same volume, as 28 tons of carbon dioxide over a 100-year period. So methane is a much more potent greenhouse gas in terms of trapping heat. However, I think it stays in the atmosphere maybe 20 years as opposed to 100, and there's much less of it at the moment. So carbon dioxide stays in the atmosphere for a century and is dispersed throughout the world. And climate, the human impact. The question that has both research and social implications. To what degree are the changes in the climate that we're observing due to human impact? In other words, to what degree are they anthropocentric, which is another key term here. That's human induced, okay? So what they do, what the climatologists do, climate scientists, they use computer models to estimate different kinds of impacts on understanding what has happened to the present and then projections of temperature going forward. And now through the late 19th and early 20th century, the models conform to the observed data pretty well. If you go backward, any model that you used. And if you look at, we have a web link there that talks about different models as well that I recommend you take a look at and get a sense of what this is. You put this thing, and then you can actually have visual simulation of what temperatures rise and fall, given if you have this factor in or that factor, and see what seems to be fitting best. And the second half of the 20th century, there's a divergence that is accounted for when human activity is subsequently factored in. Now, there are some, I think I showed there's some models slight above estimates, some below, but they're getting more precise, and you're not that far off, and they're all basically pointing in the same direction. So there's a model there of these different models to observe of how they're performing. And much of carbon has been sequestered in the ground and water. So there's a lot of carbon in the world that's been sucked in different kinds of forms, like like say ancient dinosaur, the coal sequestered carbon. And if you burn it, you release it. So that's what fossil fuels, when it's burned, the carbon is released into the atmosphere. That's why there's such a debate over fossil fuel, besides it's limited. We call it peak oil, for instance. Sequestering continues to the present. And oceans have absorbed much of the excess carbon into our present day. But when is their saturation level, when they can, more? That's why some of the models, it hasn't risen as fast as it might have, because the counteracting action of oceans has taken some of the carbon out of the air. But when we project into the future, we'll see more heat waves, disease vectors, floods, flooding of coastal cities, and low-lying island nations like the Maldives that are baked in. So the Maldives, they even have a plan that they're going to have to abandon their country. They're out in the middle of the Indian Ocean. You can see there. These could be more intense depending on the amount of temperature rise. The higher the temperature, the more disastrous the potential going forward. Here's some other things to consider. And this is not exhaustive. I have about tipping points. There's something from the Environmental Defense Fund, a blog, which really is excellent, kind of looking at different scenarios that addressing this topic here, than much more than I can put on a slide. But as the permafrost melts, methane is released. That's a positive feedback loop. And that's what happened. The largest extinction, the Permian extinction, the largest complete extinction we ever had, which was 95% of life on Earth was wiped out prior to the dinosaurs, as tribalites and some dimetrodons or whatever they were around. But you had this volcanic action and this release of all this methane. And then you can see from the permafrost, methane coming up, bubbling up. And so as the Arctic ice melts, not only you have more methane is released, explosion, because there's untold amounts of methane that are just trapped right now, as long as it's frozen. But once the ground becomes unfrozen, look out. Katie, bar the door. So as the Arctic ice melts, there's the albedo effect, and is lessened. That's the amount of reflection of radiation is lessened, since the dark sea absorbs heat while the white ice reflects it. Again, that's another positive feedback loop. And these things that trigger faster. Feedback normally kind of counteracts and keeps things within the system humming, but it's like a fever and things get out of control. Projecting into the future. As Greenland and Arctic ice melts, the salinity, that's the salt level of the Gulf Stream, decreases, not just the Gulf Stream, but all the Earth's currents, ocean currents, and the Earth's conveyor belt slows down. It's dependent on a certain level of salt water, but you get the fresh water comes off the ice, it dilutes it, right? And this is the basis on, again, what happened in the movie The Day After Tomorrow, when you kicked in a whole new ice age. So that warming current then will no longer be able to bring those mild temperatures to the British Isles. I mean, you look at where Ireland and England, Scotland, they're far north of where we are in Detroit, yet their temperatures are not all that together different because of that impact, in Europe, of that Gulf Stream coming there. So the other parts of pressure are urban sprawl and then more commuting, which we'll get in the next time. Well, it puts more pressure on fossil fuel use, which we haven't even addressed too much to the present. So a climate commitment, which means that all it means is that the Earth is going to continue to warm even if we were to stop burning all fossil fuels today. It's already baked in. Carbon dioxide remains in the atmosphere for over a century, as we've already mentioned. So that's what's been there. So, and this leads to when does the tipping point happen? And the tipping point is when, as page 77 mentions your text, when the climate system crosses a critical threshold beyond which positive feedbacks drive the system from one stable state to a new irreversible state. So that's, it's positive feedback. It's not negative. It's when it puts a damper on things. Positive, it just puts it on steroids, whatever the trend is. So what are some strategies for addressing climate change? Okay, mitigation is one. Adaptation and reconfigure food, water, building, and transportation systems. We'll address these strategies actually next week, and as we finish the discussion on climate. So we'll pick it up from page 78 to the end of the chapter, and then we'll also discuss water next week as well. Remember that you'll see the assignment tab, not discussion board, but under the assignment tab, you're supposed to submit in a couple paragraphs your area of research or topic you wish to explore. You might want to, if you're still not sure, you might want to jump ahead and take a look at the chapter in the text that corresponds to your area of interest. So you'll have about a week to do that assignment. Okay, and that one, unlike discussion board, is not locked in time contingent. So any time before the deadline, I'll take a look at it. So you want to speculate, how are you going to approach your research? Solely a library? You're going to do an interview? You're going to do some observation at a nonprofit? Another approach? What's your thought? And maybe why you want to look at this particular area of research. So this week's video resources include the classic Affluenza and Escape from Affluenza, which were first produced on public television in the late 1980s. But they're still relevant in addressing our addiction to stuff and the impact this addiction has on our souls. As the book says, we want more and more and more, and that's what's driving the economy. It's like an idea that it's like an idol. It's a totem. This is going to bring happiness, this thing, and whatever. And that's what the Madison Avenue tells us. And of course, there's only so much stuff. Again, there's no more way to throw away. So, look, this is going to be required. It's going to be recommended video. So you don't have to watch the whole thing or whatever, either video this week. But I suggest you take a look at them. I think you'll find them very interesting. Again, the other video resource is a primer on climate change from the perspective of Great Britain. And this is really good. It's about 50 minutes. Both videos are optional. I know you've got a lot on your plate, but I highly recommend. Again, maybe you can skip around through those, and hopefully that'll help you. And the drawdown text, again, although that's optional as well, provides a cornucopia of technologies. This is where it starts to kick in, and strategies that address climate change, which is, I contend, is the biggest moral issue we face, because we're talking about potential species, planetary-wide extinction, and that includes us. So